All right, boys, we got the AP test in 5 days. This is everything you need to know about forces. Let's go.
All right, question number one. It's basically asking for center of mass type. Center of mass, guys. Hey, boys, what's the center of mass equation?
Subscribe to my.
Yeah, what's the formula for center? Okay.
So I think it's fat. So it's asking for center of mass. So this one has three actions here. 3x. Now what do? We do 2 times 8 plus 3 times 4 plus 5 times 10 over 2 plus 3 plus 5, 16 plus 12, 28 plus 50, 78 over 5, 10 equals 7.8. Which one of these has 7.8? It's this one. Has to be this one. Can't be any of these. Boom, that's the answer. Pretty easy first question.
Only away from the Gooners. All right, read the question. You guys get to work. And low key. Oh, it's not that hard. But anyway, so basically, all I need to care about is that there's a box, this boy right here, and he's moving across the surface, and the friction is increasing, but the speed of the crate remains constant. So anytime you have friction increasing, what happens to the speed? The speed decreases. But this situation is not like a regular situation because it says the speed remains constant. So what does this mean? You need to compensate by increasing F applied. Okay. F tension, F applied, whatever, same thing, buddy. So over here, you see how there's one extra ticker for one extra box for the force of friction. So when we increase the force of friction by one box, what does that mean for the force of the applied force? We have to increase that one by one block, one block, I don't care. We have to increase by one block 2, okay? And then now that's gonna give us our answer, okay? So is it, which one is it? Oh, it's not, oh yeah, the slopes are way different. You see how much steeper this one is? So if you had this one, yeah, that box would be going upwards. So no. Same with this one. It's not the same slope. The boy's moving upwards, buddy. Yeah. And then C, does it look like ours? Slope of 0.5? Yeah, that's right. Because look, this one has a slope of 0.5. This one also has a slope of 0.5. It can't be this one either because 2, they would not be balanced. 1, 2. See how it's greater? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Yeah, that's not right. But this one, it is indeed balanced. Next question. So this one, it looks really hard, and let me give you guys a hint. It has nothing to do with slope, like at all. Like once you get it, boom, you get it. So anyway, I'm gonna just get started for the short attention span gooners in the chat. All right, chat. So this one, figure 1, it's basically saying there's a ball, and all of a sudden, freaking 3 forces get applied at once. Which direction is it gonna go? Is it gonna go? Okay, sorry. So what you have to do is you need to see the magnitude of each direction. So for this one, it's gonna be going up 3y, and it's gonna be going right 1x. So if we assign the positive direction to be this way, it's gonna be x, because it moves one block xwards. It's gonna be 1x plus 3y. Let me just erase this clutter so you guys don't get confused. So this one is 1x plus 3y. I'm gonna make a different color for this one. This one's gonna be negative 3x minus y minus 1y. You see, for this one. And then for this one, it's gonna be 2x minus 2y. I hope we understand how I got here, because it moves, this guy moves 2 blocks to the right, 2 blocks to the down. Okay, yeah. Right. So now, it says it's applied all at once. So what happens when we all add all of these together? We get 1 minus 3 plus 2, which is just equal to 0. Okay, and when we add all the y forces, it's going to be 3 minus 1 minus 2, which is 0. So as you can see, it doesn't move at all. So it can't be C or D. It has to be A or B. Okay, now we just do the exact same thing for this one. I'm literally going to speed it up because this is an easy problem.
So this one is 0x plus 3y. This one is going to be 3x plus 3x. Oops. You know, I was making plus negative 1y. And this one right here is going to be negative 2x minus 2y. So what happens when we add all these together? We get 0 plus 3 minus 2. So already I know it's moving in some capacity. And we also get 3 minus 1 minus 2. So that's 0. Sorry, I need to write 1 equals 0. So it's moving in the x direction. Move in x. Okay, I don't even know I'm writing that, so it has to be C. B. Alright, we good. Next question.
So this one, low-key, really conceptual. 100% seeing this on the exam. If you get this right. Anyway, short attention span. Let's go. So basically what we need to understand is force of the person on the earth and the force of the earth on the person, and also force of the person on the scale and force of the scale on the person. That sounds like interchangeable. And you know what that reminds me of? It reminds me of Newton third law pair. Let me write it smaller. And what does that mean? They're equal, but opposite. Basically, let me just draw it. We got this guy. We'll call him Daksh, because I love my Indian brothers out there. We got Daksh. So the force, so he's going to have two forces. There's going to be, we don't really care about the force of the scale, right, on the earth. That doesn't really matter. So there's going to be the force of him on the scale, which is, it's going to be mg. And then we have this force of the scale that's pushing back on him, which is going to be Fn. Do we get it? There's going to be two forces. One of them is going to be Fn and one's going to be mg. So when he's standing still, Fn is going to be equal to mg. And how can we prove that? So when he's standing still, F net is going to be equal to 0, which means the up force and the down force, up force minus down force, is equal to 0. Okay, so what this means, up force is equal to the down force, and boom, there's our proof. Anyway, this has nothing to do with the problem. Sorry, guys. Anyway, this is talking about how there's moving upwards with increasing speed. So what does this mean? That means there's acceleration. Okay, so when there is acceleration, you get F net is equal to ma, right? That's like, you need to write that every time. Pay attention, exactly what I'm doing. And then because it's moving upwards, the direction of acceleration is upwards, so that means you put that word first. You put up force minus the down force. It's not going to be the down force minus the up force. It's going to be up force minus the down force, okay? Remember that. It's moving upwards, put that first. Okay, so what's the up force? Oh, good job, me. I put it Fn minus mg is equal to ma, okay? So this means that when it's accelerating upwards, the normal force is equal to ma plus mg. And then, shoot, I should have done this in the beginning of the question, but all this mumbo jumbo, you can replace this with Fn, and you can replace this with Fmg. That's basically how you say force of earth on the person.
Bro, that's just another way of saying your weight. Like,
Are they slow? Like, why are they overcomplicating this stuff, bro?
Force of the scale on the person, bro, that's just another way to say normal force, okay? So, as we know, the force, when it's accelerating upwards, when going up plus accelerating, the normal force is greater than mg. Why? Because there's an ma. I don't know how much easier I can explain this, but like,
there are bigger fries to put in the bag.
So anyway, this is how you know. So because now we started eliminating answer choices. So as you know, these are they need to be in pairs. So FP and E, these need to be equal to each other, and these need to be equal to each other. All right. So it can't be this one because they're not equal to each other. This is so wrong. It's not this one because these aren't equal to each other, and it's so wrong. So it has to be either C or D. So which one of them says that Fn, the normal force, is greater than mg? Good job, guys. Force, your normal force is always going to be greater than your weight when you're accelerating upwards. When you're accelerating upwards while going upwards, or you're accelerating downwards, or you're decelerating when you're going downwards. No, accelerating downwards when you're going downwards. Sorry, guys. Misinput. Anyway, this one is like not conceptual at all. So if you get this right, I mean, at least you have like the basics down. But once it gets conceptual, that's how you know you got your stuff down. But this is just basic. So how do we do this? So anytime there's acceleration, you always know that F net is equal to ma. If there's no acceleration, you can just put this at the top. F net equals 0. Because if there's no acceleration, a is 0. You just cancel that out, okay? So F net equals ma. So now what? What? I'm gonna give you guys a quiz. Is F net equal to up force minus down force or down force minus up force, and why? Take a moment, put that in the comments. Well, the answer, it's always gonna be up force minus down force, and the reason why is because the direction of acceleration is up, which means we always put the up force first. Like clear, up force minus down force. So now, what's the up force? The up force is going to be tension, and not just one tension, not just one T. It's gonna be 2T, because we have two freaking strings. Guys, I'm gonna keep it a buck. I got it wrong because I thought there was only one tension, but if there's ever more than one string, that's 2T right there. So the up force is gonna be 2T minus the down force. The down force is always gonna be equal to mass times gravity, mg, your weight, equals ma. So now, it's asking us to find the tension force. So let's just isolate T real quick. Ma plus mg. And now let's just start substituting. It gives us the m. The m is 10 kilograms. So 2T equals 10 times acceleration. Oh my gosh, this is so easy. They're literally giving us everything, which they're never doing on the real test. So we get 2T equals 20 plus 100, which is 120. So that means T equals 60. Yes! Let's go! Alright, for question number 6, it's asking for the net force. So what's the formula for net force, guys? Net force is going to be equal to ma. Okay, or another way of writing net force is writing F net is equal to direction of acceleration. We just talked about this, guys. If you don't remember this, so the direction of acceleration in this case is going to be towards the star, because the planet is trying to go towards the star. I hope that's obvious. Like the Earth is trying to go to the star, but guys, okay, like it's not trying to go to the other planet, right? It's orbiting the star, which means its direction of acceleration is toward the star. Right force minus the left force, because the right force is the direction of acceleration. I'm just pointing that out. And the right force is going to be equal to the gravitational force. Okay, and how do we calculate that? Equals, that's not gravity, that's gravitational force, which is not the same. G m1 m2 over r squared. So the right force is going to be G times m1 times m over r squared. And why is it m? It's because there's a fat m, there's a little m. Okay. And then, so I'm going to remove the subscript real quick, because there's no m1. It just gives it to us in terms of m. There's no like subscripts here. There's no imaginary. So minus the left force. The left force is G m 2m over r squared. Where did I get the 2m from? It's that. Where did I get the r squared from? It's that. So this is our answer, F net, but it's not simplified. You see how all these answers are simplified? What we need to do is we need to distribute the G, the m, and the r squared, right? So what do we get? G and the r's cancel out, we get m, minus G and the r squared, cancel out, minus 2m. That is our answer. What is the answer? This one. Yes! Next question. So this one, freak, we actually have to do conceptual questions. I know, but I'm okay. I don't know about you guys. But anyway, there's gonna be, you guys, okay, I gave you enough time. So there's always going to be a normal force that acts perpendicular upon the surface, it's resting on. The force is exerted on. There's always gonna be a perpendicular force. So let's say the wall's like this, it's gonna be perpendicular to it. Guys, what does perpendicular mean? Oh shoot, it needs to be equal to FA. It's whatever, guys. You know what I'm doing. You know what I mean, right? It's like, so perpendicular means it forms a 90-degree angle. So this is gonna be Fn. Okay, and let's say if it was like this, and there's a box like this, the normal force is gonna be this way. It's not gonna be this way. Do we get it? It's always gonna be perpendicular to the wall that it's resting on. W example by Michael Penning. Okay, anyway, next. So it's asking for the force of static friction. So this entire block, what we need to realize, it's not moving. It's held at rest. And what this means is that F net is equal to 0. Okay? So that means the up forces is equal to the down force. And then the right force force is equal to the left force. I hope I'm making sense here, because if there was acceleration, these would not be equal to each other, right? Because yeah, but because it's held at rest, F net is equal to 0, which means they're equal to each other, because you're holding it at rest. Like, let's say the normal force was super big, right? Okay, I'm gonna erase all this. Let's say the normal force was super big. Then the block will be flying this way, wouldn't it? But because they're equal, it's held at rest horizontally. And now what we need to realize is that there's a force of friction this way, and there's going to be equal and opposite force, mg. Okay? So, because F net is equal to 0, the down up force is equal to the down force, which means FF is equal to mg, which means D is correct. Because if it was not equal to mg, it would be flying all over the place. If it was greater, that boy would be moving upwards, wouldn't it? All right? Okay, next question. All right, boys, for question number 8, do not be fooled. It looks a lot harder than it actually is. But basically all it's asking for is the spring constant, which we know is K. Okay, so first, we're going to use F net is equal to ma. And is there any acceleration in this problem? Is there? And the answer is no, it is not. Why? Because it is held at rest. Held at rest. So that's how you know F net is equal to 0. And now, what we did for the last 5 questions, we're literally just going to keep doing, which is the direction of acceleration. In this case, I'm going to let you guys figure it out. Think very hardly. Is it going to be upwards or downwards? The answer is upwards, because as you know, the spring, it wants to push it back this way. Like if you pull a spring this way and then you let go, it's going to go back this way. Guys, we got Michael explaining springs before GT8. Anyway, so it's going to be up force, which is kx, minus the down force, which is mg. Or is it? Here's the thing, right? Force is on an inclined plane. Like, guys, I could pretend like I know how to explain it, but there's like this really cool guy named... He's a good friend of mine. His name is Organic Chemistry Tutor. Basically, I'm going to link a video down below. Basically, what he tells you is this is mg sine theta, and then this is mg cosine theta. All right. So I'm just going to use that. He's like a pretty small content creator. So this force over here is actually going to be mg sine theta. Okay? Link down below. Mg sine theta equals 0. So now we have to find k. How do we isolate k? So first we have to move this to this side. So that's going to be kx equals mg sine theta. Just now it's k equals mg sine theta over 2. Or I mean x, mb, guys. And that is going to be c. All right, JDs and gentlemen, this is question number 9. This is like my 5th time doing this because I keep getting interrupted or distracted. But anyway, I'm just doing it right now because lunch is in like 2 minutes. So anyway, the first thing we need to do is we need to realize that the force of tension is in this big freaking string, right? So this is Ft. And then, because it's held at an angle theta, you know there's going to be horizontal and vertical components to the force of tension. So that means over here, this is going to be the vertical component, and this one right here is going to be the horizontal component. Anyway, so, as you know, the up force is always Ft cosine theta, or frick me, sine theta, and the horizontal force is always cosine theta. But in this case, you see how it's not facing horizontally, it's facing diagonally, right? So what we need to do is realize that this side is actually Ft cosine theta, and this side is Ft sine theta, and it's not always sunshine, rainbows, x equals cosine, y equals sine. This is wrong because it could be facing in an opposite direction like that, okay? Are we clear? Anyways, these people are going to start coming in for lunch, so I need to hurry up. Anyway, what else are we given? We're also given L. And what can we do with L? We can realize that L is this right here, and this is L cosine theta, and this is L sine theta, okay? Which means if we were trying to look for the radius, what is the radius? The radius is essentially given to us. The radius is this stuff right here, and we're given that it's L sine theta, right? So now, what equation can we use to try to find force? I don't care about tension, we're just force in general. We can use F equals ma, right? Right? So now we can use Ft equals ma. So, we're not really given acceleration. Can we find any other way to find acceleration, like at all? We can use centripetal acceleration. Oh my days, right? It's equal to v squared over r. But we can't use it like how it is right now. Like if we just did this, it would be so wrong. Like I literally did this on the test and I was wrong. That's how I got it wrong. What we need to understand is that whenever an object is moving in a circle, right? What is the force that makes it move in a circle? Is it the vertical force or is it the horizontal force? I'll give you a second to answer that. It's obviously the horizontal force because the horizontal force points towards the middle. That's the centripetal force. It's not the vertical force, right? Otherwise that wouldn't be moving in a circle. Yeah, okay? So it's always the horizontal force that's pointing towards, okay, I hope I'm making sense here, right? The horizontal force, I'm gonna put it in green. It wants to go this way, it wants to go this way, it wants to go this way, it wants to go inside. Am I clear? So anyway, so now we understand it's not Ft, it's not any of this. It should be the horizontal force, which is Ft sine theta is equal to mv squared over r. Okay? So now what we do is, what is r? Well, I literally just told you what r is. R is L sine theta. Holy, I need to go eat. Ft sine theta is equal to mv squared over L sine theta. So now, it's asking for force of tension, so we have to isolate Ft. So how do we do that? Ft sine theta is equal to mv squared over, you multiply both sides by 1 over sine theta to cancel it out, so it's L sine squared theta is our answer. And there we have it. I finally get it. I'm learning with you guys. Anyway, time to go eat. Alright, so when we're looking at this question, I'm going to just let you guys read it. But basically what we need to realize is that when something is at rest, that means that the up force and the down force, they must cancel each other out. They must be equal to each other. Yeah, and then the right force must be equal to the left force. So, what are some answer choices we can immediately eliminate? So first of all, the right force is going to be the applied force, and then the left force is going to be the normal force. And what do we know about the normal force? I literally just said this like 3 minutes ago, but the normal force is always perpendicular to the surface the applied force is acting upon. So in this example, the applied force is acting this way towards this wall. What is perpendicular to the wall? It's going to be this normal force, which I'm marking in red. The normal force is going to be this way. So that means we can eliminate choice D, because the normal force always forms a 90-degree angle. That boy is definitely not a 90-degree angle. Okay, so let me just erase all this. So other three. As we know, the up forces and the down forces have to cancel out. And if you saw question number 3, whenever you have an object moving diagonally, there's always going to be two imaginary, or you're always going to have like a vertical component, and you're going to add that over here. And what do you know? That makes it so the up force is greater than the down force. So this means the forces are not equal, so this is wrong. Same over here. We have a vertical force here. Is this right? It is indeed right, because this one, yeah, this one's right. Because the horizontal forces also cancel out. 1, 2, 3, 4. 1, 2, 3, 4. They're the same. And then how is this one wrong? Well, if you add this one here. Oops, why do I keep doing that? If you add this force here, add it up top. Oh, that's equal, right? But you also need to realize this is only 1, 2, 3. And then this one is 1, 2, 3, 4. So these horizontal forces do not cancel out, which means it is going to be B. Alright, last question before I got to go bed. Alright, time to get started with this one. Just pause if you want to do yourself one anyway. So this one's asking all about center of mass. So what do we know about the center of mass formula? The center of mass is going to be equal 2. So let's write some center of mass OG because it's telling you to double it the second time, but the first time it's just regular. So what is the OG one? It's going to be x1 times m1. And what is x, by the way? X is going to be the distance from the mass to the center, and the center is labeled right here. So that is x. And then I'm going to use a different color for x2, which is going to be this ball, this little boy, plus x2 m2, which is going to be x2 is going to be this distance. Oops, terrible line. And then we also can't forget about x3. And you're like, what the frick is x3? It's the rod itself, right? Because, yeah, there's a rod that's holding it all together. So I'm going to write in that one blue. And how far away is it from the center? That's a trick question because it literally tells you it's centered on x0. So if the x is 0, this cancels out, which means this is the center of mass of the OG. Actually, wait. You also got to divide that by m1 plus m2. Oh, and m3, because this time there's no 0 to cancel that out. Am I making sense here? Because before, it would be x3, m3, and then x3 would be 0, so this would cancel out. But now, m3 isn't being canceled out by anything because the rod still has a mass. Anyway, now let's see it after it gets doubled. See, center of mass after. This is like, yeah. So now everything gets multiplied by 2, right? Because, hey, let me just write the idiot way. Right, because you can just factor out a 2. And then on the bottom, I'm going to write the way you're supposed to write it, m1 plus m2. So it says the mass of each of the two spheres is doubled, but the mass of the rod does not change, which means the mass of the rod, which is m3, does not change. So now what happens to it? Basically, let me just write it the real way, because this is actually like, it's PMO, I'm going to be honest. Keep it a buck, guys. Over 2 m1 plus m2 plus m3. So basically, let's say you were to have a number. I'm going to just make it easy for the small brains to understand. Let's say you have a number, and it's 1 plus 1 plus 1. So what is the answer? It's going to be 1 plus 1 plus 1 is 3, 6. But now, let's say you leave one of them out. Now what happens? 2, 1 plus 1 plus 1. So now it's going to be 4 plus 1, and it's only 5. As you can see, this one is smaller, okay? And when you have a smaller number in the denominator, it's going to yield a bigger number. Am I making sense here? So let's say 10 over 6 and 10 over 5. Which one gives you a bigger number? It's going to be 10 over 5. Guys, I'm just trying to make it really easy for the small brains. No offense to you guys, okay? If I'm making sense. So now you know it's going to yield a bigger, smaller denominator equals bigger number as a whole. Okay? So which one gives us a value that's bigger than xcm? Is it between x0? No, that's less than, because 0, that's that. Is it at xcm? No, that's still less than. Is it at xcm? No, so it has to be D. It's greater than xcm and 2 xcm. Okay, I'm a dip. Bye. All right, for this next question, it's asking about rope, bucket, altogether moving. So I'm just going to assume that this means constant velocity to make my life easier, because I'm a smart guy like that. And what do we know about constant velocity? That means F net is equal to 0. So what is the direction of acceleration in this case? Guys, we've literally gone over this 100 times. It's going to be upwards, which means we're going to do up force minus the down force is equal to 0. The up force is going to be the Ft, force of tension, minus the down force, which is mg, equals 0, which means Ft is equal to mg. So how can we use this? Like, how is this in any way relevant? So let's just start eliminating answer choices. Question A, the force the rope exerts on the bucket which is just Ft, is greater than the combined weight, which is wrong because we literally just proved that they're equal. What else? The force the bucket exerts on the rope is in the opposite direction of the force of the rock. So the rock exerts it this way. The bucket exerting the rope is also this way, which means they're in the same direction, which means it can't be B. The force the rock exerts on the bucket is equal in magnitude to the force the bucket. So this is a Newton's third law pair. Oops. So this is just simply a Newton's third law pair, and equal in magnitude just solidifies that yes, they are equal, because that's the Newton's third law pair. Literally, rock on bucket, bucket on rock, they have to be the same. And why is D wrong? The force the bucket exerts on the rock is greater in magnitude than the force the earth exerts on the rock. So the force earth exerts on the rock is just mg, and then the bucket exerts on the rock is just the normal force, and the normal force has to be equal to mg. So can't be right. This can't be right. So there, boom, there you have it. C. Oh, also the reason why Fn has to equal mg is because it's not accelerating upwards. If it was accelerating upwards, the normal force would probably be greater, but because it's constant velocity. Also, the question is really vague. Like, it doesn't specify whether or not it's constant velocity or acceleration. So you can just assume it's one or the other. And if you assumed acceleration, you probably got the question wrong. But if you assume constant velocity, you got it right. Okay. So for this next question, it might be like one of the easiest questions I've ever seen. But translational equilibrium basically means that it's moving constant velocity and that A is equal to 0. So what does this mean? If there's projectile motion, that means there's going to be, let's say there's a ball thrown that way, there's always going to be the force of gravity. And gravity is equal to 9.8, which is not 0, so it can't be this one, okay? There is acceleration. A car turning a corner on a blip. So turning a corner means the car has to go this way, which is in a circular motion. Anytime there's circular movement, there's always going to be centripetal acceleration towards the middle, so it can't be this one. Sledding at constant velocity. Bro, textbook definition of translational equilibrium, it has to be this one. And why is this one wrong? Ball being swung in a vertical circle. So yeah, anytime there's anything circle, there's always acceleration towards the middle of the circle. It can't be this one. Okay, cool. All right, this next question is basically asking you to find the acceleration. But what we can do is just find the net force, okay? And the net force, we have to find every single time. We just write at the top, F equals ma. F net equals ma. So, once we know the F net, we can basically find the acceleration. So what I mean by that is for this one, F net is equal to how many m's do we have? We have 1, 2. So we have 2m. And then how many accelerations do we have? We have positive acceleration and then positive acceleration. So we're going to do a plus a. Okay? For this one, F net is equal to 1, 2, 2m. One is a negative acceleration, negative a, and one is a positive acceleration, positive a. For this one, it's going to be F net is equal to 1, 2, 2m times 0, because this one doesn't have an acceleration, it doesn't have one, plus 0 minus a. Okay, so now when we simplify everything together, we get 2m, 2a, and for this one, we get 0, because the a's cancel out, everything becomes 0. This one becomes 2m minus a. So let's use our common sense. Which one is the biggest? Which one is the least? So the answer is going to be, this one is number 1 because it's 2m, 2a. This one is second, and then this one is third because it's literally 0. So it's going to be A, C, B, which is going to be C. Can't be these ones, can't be these ones. All right, for this next question, it's asking for the object's weight on a hypothetical planet. So anytime it mentions weight, you need to know about the gravitational field strength formula, which is gravitational field strength formula. So this just says how much gravity a certain planet has, and it's going to be equal to gm over r squared. So let's just say Earth has a mass of 1 and then has a radius of 1. So Earth, I'm going to put it up here, is going to equal g1 over 1 squared. So it's just going to be equal to g. Okay? And now let's do a hypothetical planet in red. So fake planet, it says it has twice the radius and then twice the mass. So now it's going to be g. So it's going to have twice the radius, now it's going to be 2. It's twice the radius, or twice the mass, and then twice the radius. So now it's going to be equal to 2g over 4. So it's going to be g over 2. So what's the weight on the surface of the hypothetical planet is going to be g over 2. Which one of them gives us that? A, we over 2. Because you know g is equal to we. Okay? Can't be these ones. Oops, I should have, yeah. Next question. So for this next question, it's asking about springs, tension. I know it looks really hard. I just spazzed out on this one, but as long as you've been doing what you've been doing the past like 5 questions, which is just write F net is equal to ma every single time, you're gonna get it right. So F net equals ma. Is there acceleration, or is F net going to be equal to 0? There is, because there's constant acceleration. So anyway, so let's find F net of this cart, because there's 2 different carts. There's gonna be 2 different F nets. Do we get it? So F net of this cart over here. Let's call this one, I don't know. Let's call him Kevin. So the F net of Kevin Nguyen, is going to be the direction of acceleration, which is this way. It's getting pulled that way. So it's going to be the right force minus the left force is equal to ma. So what is the right force? The right force is Ft minus the left force, which is kx, because that's the spring. And now, you've never seen this on the AP exam, but they're going to be giving you the freaking values. It gives you 1,000 as the spring constant. It's going to give you the rope force. The force of tension is 100. So we're going to substitute Ft as 100 minus k. K is 1,000 times the spring is 0.06 longer. That's just another way of saying displacement of the spring. Then it's relaxed length, so you do 0.06 is equal to the mass, which they also give, times the acceleration. The acceleration we're not given, right? Yes, we're not given. So 1,000 times 0.06 is the same as 100 times 0.6, which is just 100 minus 60 equals 2a. So that's 40 equals 2a, which means a is equal to 20 meters per second squared. So it's not even asking for that. It's asking for m. So how do we find m? So we're going to do the exact same thing. Let me just erase this. Now we're going to do it in blue. So now we're going to find F net of this guy. We're going to call him, I don't care, Michael. F net equals ma. So what's the right force? The right force is going to be kx. And the left force is nothing. There's nothing pulling it, and there's no friction either. Is equal to ma. What did it say? That's 1,000 times 0.06 is equal to m, because it's a fat m, times 20, because we just found it. So this is 60 equals 20 m. M equals 3 kg. So it's a. All right. Looks hard. That might be the easiest thing I've ever seen. Anyway, next, this is very, very conceptual. You need to understand this. So basically, it's talking about this guy, vertical, swinging object. So let's just draw the object. It's going to be a ball. And he's swinging it vertically. There's going to be a string over here. So anytime you have a ball and you're swinging it in a circle, there's always going to be mg. So I'm going to draw mg as red. This can be mg. But what keeps the ball up? It's going to be the force of tension. Okay? So what happens when you stop swinging it? Then the force of tension becomes 0, right? And then it's just mg, and then that just caused the ball to fall all the way down, right? So this is asking for the minimum speed the object can have at the highest point and still stay in circular motion, right? So Ft, this must mean that Ft is equal to mg, because when Ft is equal to mg, it's the minimum force required so that it doesn't fall towards the ground due to gravity, okay? So now what we need to do is we can find that Ft is centripetal acceleration, basically, because it's what's keeping it up. So it's going to be mv, Ft equals ma. Ma can be substituted as mv squared over r equals mg. Cancel out the m's. V squared over r equals g. V squared is going to be equal, is what we're trying to find actually. So we're going to do V squared is equal to gr. V is equal to root gr. V is equal to root 10 times 0.4. I actually don't have this. So that's just, oh, actually it's just 2. Because 10 times 0.4 is just 4. root, so it's going to be C. I'm actually going to do this part again because you guys, I kind of explained it quickly. So Ft is only equal to mg when it's the minimum force required. Because if it was less than mg, then mg would overpower it and the ball would start falling down this way. Am I clear? So Ft is always equal to Fnet, which is always equal to ma. All right? Anytime you have any force, it's always equal to ma. So now let's do ma is equal to mg. Cross out the m's. A is equal to degree. How else? What's another way of saying a? It's going to be centripetal acceleration, so which is just v squared over r equals g. And then that's how I got there. V squared equals rg. Right? If you look on the formula sheet, it's on the AP Physics 1 formula sheet. A equals v squared over r. And we're given r, so perfect. Let's go. Okay? Very conceptual. If you got this right, let's go. Alright, for this next question, it's asking about center of mass. So there's going to be an OG toolbox, and it's like perfectly balanced. And then there's like a new toolbox, right? And this is the new one, and then all of a sudden it starts leaning to the right. Okay, so what can we conclude about the toolbox? So for question, for choice A, it's saying the mass is left, which is wrong because if it had more mass over here, it would be leaning this way, wouldn't it? So this one's wrong. And then also the center of mass on the toolbox is left, can't be right. So now it's just a choice between B and D. So B is saying that there's more mass over here than over here, which sounds right. And then D also says center of mass is to the right. So how do we know which one is the more correct answer? Because I guess they can both be correct, but this one, for B, we need to realize that center of mass is not just just mass, m1 plus m2 over m1 plus m2. That's not the right formula. It's x1 plus x2, right? So theoretically, what can happen that let me disprove B. So we could have 50 kg over here, and this is the middle, and then we can have 50 kg here, and it would tip which way? It would tip this way because the mass is farther away from the 0 point. So let's say the mass on the left side had more. Would it still tip? Well, let's think about it this way. Let's say this one had 50.000001 K. Theoretically, it has more mass, but it means nothing because the position is still way less than on this side. This one is only 2 meters away, and this one is like 6 meters away. Okay? So that's a situation when it has more mass, right? It has more mass, but it still doesn't lean that way. So it can't be B, it means it has to be D. Okay? Hopefully that wasn't that confusing. The position matters a lot for center of mass as well. Okay? Next question is talking about force of friction. So anytime you're pulling on an object and it doesn't move, let's say you have a ball and you're pulling on it with 50 newtons and it's not moving. The force of friction is always going to be equal to it. It's only when you exceed the force of friction, let's say you need to exceed 100 newtons. Once you go to 101 newtons, then you're going to start using the coefficient of kinetic friction and not static friction. I know it sounds like a lot, but just know that it's always equal to, when it's at rest, the friction force is equal to applied force, okay? So we're just, let's focus on that. So let's, as you can see, it's unable to get the black to slide, which means it's at rest, which means the friction force is equal to the applied force. The applied force is 26 newtons, and it's going to be cosine because it's the x direction. 26 cosine 30 degrees. Cosine is root 3 over 2 times 26 over 1. This is 13. 13 root 3, which is 23 newtons, which is this. Alright, so for this next question, it's asking about spring. It's hanging vertically from the ceiling. So it looks like this. And then there's a block over here. So this is at rest. But when you add a mass over here, let me just add a mass way here, it goes down. Let me draw a new spring. Now it goes down this much. So this new length is going to be delta x. Okay, let me just erase this. So now it's asking if there's quadruple the mass, how much new delta x will be added. So this one is, I just did it in my head basically. So if you know that m displaces it root x, I just multiplied both sides by 4, displaces it by 4x. So now you get the initial displacement over here, which is L0, and then you're just gonna add 4x to it. 4 delta x, which is d. Alright, question 21. Listen, I'm not even gonna try to pretend like I know what's going on here. The way I understood it, I actually watched a video. I'm gonna link it down in the description. I genuinely couldn't wrap my head around this one, so sorry about that. But definitely check out the video linked in the description. Okay. All right. So this next question is also asking all about friction force. So there's two friction forces. There's gonna be Fa minus V. So this is the friction force over here. And then there's also B minus F, which is between the box and the floor, which I'm going to put as blue. So basically it's asking, when you add another box, what happens to the friction force? So how do we calculate friction force? Is it FF is equal to mg mu, and mu is just the coefficient of friction, right? So as we can see here, it's directly proportional to m, right? So as m increases, the force of friction also increases. So when we add another box that has mass m, that's how you know the force of friction increases throughout the entire system. So that means it increases here, and it increases between A and B, and also B and 4, which means it's D. Okay? So for the next question, it's really conceptual. Basically, it's asking if you have a wall, and you have a spring on the wall, and it's super compressed, and you're holding the block, and then you let go. What's the force of the spring? And then also, what is the speed of the block? So the block is initially at rest. So when you let go, the speed is going to be increasing. So it's either A or it's going to be C, because it can't be decreasing. How do you go slower than rest, than not moving? You know what I mean? So it's either A or C. So is the force exerted by the spring increasing or is it decreasing? So whenever you have whenever you are holding it against the spring, right, it's going to be at its maximum potential. As soon as you let go, that spring is going to be in contact for another like split second, and then it's going to stop touching it. So like, you know what I mean, right? So after like 1 second, the spring is going to be compressed, and the block is no longer going to be touching it anymore. So it's going to be decreasing over time. Okay, so it's going to be C, not A, not B, not D. Okay? All right, so this question is asking about friction on two boxes. So you just need to think about it like this and like this. There's no, or let me make the other one in green. So this is the small one, this is the fat one. This one's A, and this one's A, this one's B, right? So it's asking for the ratio of kinetic friction. So how do we find friction? Friction is just mg times the mu, or the coefficient of friction, okay? So we just need to calculate the mg, the mass, and then boom, then we get our answer. So this one is saying some BS about volume, and volume has nothing. It has nothing. It does not relate anything to the force of friction or the mass, surface area. You don't really need that. All you need to know is that QB has twice the mass of cube A, which means the mass for this one is going to be 2g times mu. This one's going to be, let's just say it's 4g times mu. Okay, so the coefficient of friction is going to be twice as big, so it's going to be 1 to 2. That's our answer. So this question is asking about a mass that's at rest at the back of a truck, right? So you need to know that whenever the object is at rest, the net force is 0, which means the up force is equal to the down force. They cancel out basically. And then the right force is equal to the left, right? So in this diagram, it says there's an error in this diagram. So what I can clearly see is that the top or the up and down forces might be balanced, or they are, but the left and the right are clearly imbalanced. Like you have this guy right here, and then you have no left force to counteract it. So let's see which one of these answer choices says basically that. So is there something wrong with the normal force? It should be directly vertical upward. No. So this is wrong because the normal force, like I mentioned before, it always is perpendicular to the surface it's being applied to. So it's not this one. It'll never be in the same direction. That's wrong. It's always perpendicular to the surface the force is exerting onto. For B, the magnitude of gravitational force is always equal to the magnitude of normal force because the normal force is not always the object's weight because let's say you're going down on an elevator, right? The problem we were doing before, right? If you're accelerating downwards at a constant speed, you're gonna feel heavier. So it can't be this one. The magnitude of friction should always be less than 1. That is not true because the coefficient of static friction can be any number. It can be greater than 1. It can be greater than 1. So that means it's D is the correct answer. Friction force should be directed up the ramp because the box is slowing down. Yes, this is correct. It should be opposite of the direction of motion. So what it's basically saying is that there should be another vector over there that opposes the direction of motion. Okay? Next question. I'm going to let you guys read it for maybe 10 seconds. It's asking, are these two forces a Newton law pair? And which forces is it asking about? It's asking if gravitational force exerted on the rover by Mars and tension force exerted on the rover by the core. So immediately, if you know what a Newton's third law pair looks like, let's just go back to example number, I forgot, but it looks something like this. Scale on person, force of, and then force of person on scale. This is what a Newton's third law pair looks like. And what I'm seeing here, this is one of them is talking about tension force and one of them is talking about gravitational force. So the answer is no, but which one provides the right justification? So this is not, no, because they're not equal in magnitude in opposite direction. This is not true because it doesn't give you any information about tension force or the gravitational force. So it has to be D because these forces are not an interaction between the same two objects, right? One of them is the rover on the cord, and then one of them is the rover by Mars. All right, so this next question is low-key kind of tricky, so I'm going to give you guys some time to comprehend it, right? So I just want you to think of it like this way. So you need to think that this rope has a vertical component, and then there's going to be a horizontal component, right? So because you might be thinking, right, hey, is it not going to just move this way? But if you read the question, it's attached to a wall, right? So it's not going to be moving. But basically, the more the rope is put this way, the more the force rope 1 has to use to counteract the force, right? If the rope was like only 1 unit long, the tension, T1A, will just overpower the force, right? So the longer or the more horizontal the force is, like this one right here, like, let me just give you an example. If it was going like, let me just erase all this. If the force was going like this way, the tension would be a lot greater in T1A because it would have to use a lot more force to balance out the horizontal force here, right? So this one right here has a lot less horizontal force, which means the tension can relax a little bit more, right? It doesn't have to use as much force to try to balance out balance out the forces. So which one of these answer choices is right? Is tension in both situations the same? No, it's not. Because this one has a bigger horizontal component. Is it 0? No, it's not. Is it because it's the vertical? So the vertical component has nothing to do with this in this situation, because you're focusing on these two, right? And this is a horizontal component, right? It doesn't really care about the vertical component. It cares more about the horizontal component, which means it's D. Next question, block of mass M. All right, you guys got that. So here's what I need you guys to learn for this one. Anytime it says free fall, you always know F net. Oops, let me just write that a little bigger in green. F net is equal to mg during free fall. Okay. Okay. So let's just write the up forces and the down forces. So the up force, actually no, the direction of acceleration is downward. So we're going to do the down force minus the up force equals mg. So the down force is mg minus the up force, which is t, which is equal to mg. Okay? So as you can see, mg minus t equals mg. T has to be 0. So the tension force in this system has to be 0. So it's asking which of the following correctly indicates the acceleration. So like I said, acceleration is always just equal to gravity. So it can't be less, can't be less than gravity. Is it equal to g? Because the force exerted on the string and the block. So there's no force exerted by the string because you know tension is 0, right? So it can't be B, so it has to be A. Equal to 0 because the tension in the string is 0. Block is in free fall. Yep. Alright, and there we have it. Done, done, done. Alright, anyways, we've reached the end of the video. Sorry guys for not uploading daily. But okay, bro. On Thursday, dude, we had like an NCS game for volleyball. Put a clip right here. Dude, that was like top 3 best games of my life, dude. But we ended at like 12 because it was all the way in Concord. So 3-2 reverse sweep BTA. Alright, anyway. Friday, I low-key could have popped a video out, but dude, these questions are hard, man. Like those forces questions. Like, I need to understand it too. Like, I'm not just gonna say some like college board answer. Like, I need to like say it Michael style, you know. So Saturday I was a track meet yesterday. Let's go watch it. But Sunday, I'm locked in. Even though it's like 10 p.m. right now. But anyway, thank you guys so much for the support recently. Please leave your questions in the comments or something, or just leave a like. Make sure you subscribe so you don't miss out tomorrow. All right, I'll catch you guys. Bye.